My name is Jim Pollitt of the Water Resources Management Division. Many of the public drinking water systems in Newfoundland and Labrador use a chlorine solution of either sodium hypochlorite or calcium hypochlorite to disinfect their drinking water. The chlorine solution is commonly injected using a chemical feed pump. Chemical feed pumps are also known as chemical dosing pumps or chemical metering pumps. During this video, I will discuss regular operation and maintenance requirements of chemical feed pumps and provide some basic information around problems that can be encountered and how to address those issues. The information provided is intended to be general in nature. Contact information is provided at the end of the video for any community that may have questions related to their specific system or situation. When working with chemical feed pumps and chemicals, safety is paramount. It is necessary to understand the hazards posed by such chemicals and use the required personal protective equipment. Requirements for safety equipment will vary according to the chemical or chemicals in use. The safety equipment discussed in this section is for use with sodium or calcium hypochlorite. Depending on the chemicals in use at a specific location, other safety equipment may be required. Operators should always wear a face shield or safety goggles, chemical-resistant gloves, and rubber boots when working around chemicals. The applicable safety data sheets, or SDSs, for all chemicals used should be available and stored in a location where they are easily accessible. Ensure all chemical containers are labeled and stored as required by WEMS guidelines, and at any location that chemicals are being used, there should be an emergency eye wash and shower station installed and operational. Prior to using any chemical, operators should obtain and review the applicable SDS. There are many different suppliers and brands of chemical feed pumps, including Grundfos, Prominent, Milton Roy, Pulsatron, and numerous others. Knowing the brand and model of the chemical feed pump being used is important. Each community should have a brand-specific operation and maintenance manual that provides details for that system. O&M manuals are essential references for operating, maintaining, and troubleshooting your chemical feed pump. If you do not have the manual for your system, reach out to your regional operator trainer or equipment supplier to find out how to obtain a copy. Additionally, certain pump specifications can be found on the pump nameplate. Refer to the nameplate for information such as pressure rating, pump capacity, power requirements, model and serial numbers, and certifications. Pump nameplates may also include information such as the manufacturer and information on maintenance kit stock numbers. Chemical feed pumps are used to inject a precise amount of chemical or other substance into the water. Within your water distribution system, chemical feed pumps are often used to inject chlorine solution into water supplied to the distribution system. A chemical feed pump is made up of the following parts: the system controls, including the display screen, control knobs, and indicator lights where applicable, the drive unit, which houses the operational parts of the pump, and the liquid end, where the suction and discharge valves and lines are connected. Chemical feed pumps can be controlled manually, whereby settings are adjusted by control knobs, or they can be digital, whereby adjustments occur through a series of digital menus. There are three options for controlling chlorine dosage: solution strength, stroke length, and frequency. The most effective way to operate is to keep two of these factors constant and have one variable. It is recommended that the solution strength and stroke length be held constant because in most systems, frequency is controlled by a flow meter, which is constantly changing with flow. Operators can adjust the quantity per stroke to increase or decrease the chlorine residual. If the pump has a frequency knob and no flow proportioning from a flow meter, then this just requires adjustment of the knob. If a flow meter is involved, then frequency adjustment would be achieved by a pulse signal or a current signal input from the flow meter. This signal increases or decreases with the system flow rate. The setting of the flow range is also important. It is normally set between the maximum design flow for the system and zero flow. If the flow range was expanded, then the chemical dosage control would be less precise. For example, if we change the high range from 50 gallons per minute to 100 gallons per minute, at 50 gallons per minute we now get half the frequency. The narrower the range window, the more precise the chemical dosage control is. There is an existing video titled Hypochlorination available on the Newfoundland and Labrador Water Resources YouTube channel that can be referred to for more information on the preparation of sodium hypochlorite solution. Depending on what type of pump you have, injected chlorine solution flow rate may be provided on a display screen. Operators should know which units are being displayed. Commonly used units are liters per hour, milliliters per hour, or gallons per hour. For systems without a display screen, the chlorine injection flow rate is based on the position of the stroke knob, volume stroke, and the frequency, usually strokes per minute, of the pump strokes. For systems without a display screen, the chlorine injection flow rate is based on the position of the stroke knob, volume per stroke, and the frequency, usually strokes per minute, of the pump strokes. Many chemical feed pumps can be programmed to operate flow proportionally, whereby the amount of chlorine solution injected is controlled by the flow of the water to the distribution system. This is a flow-paced system where the metering pump works in communication with a flow meter and adjusts based on water demand. They can also work manually or independently of a flow meter. In manual mode, the chlorine solution is injected at a set rate regardless of water demand. Before we begin discussing common issues, operators should note that one of the best sources of troubleshooting and maintenance can be found in the pump manuals. There is usually a section at the back which lists common problems and possible solutions. Some common issues that are regularly encountered with a chemical feed pump include looping or bending of the chlorine injection line, improper pump or flow meter settings, broken equipment or components, air bubbles in the tubing, ruptured or damaged diaphragm, and clogged injector fittings. Now let's discuss these issues in more detail. The most common cause of a pump failure is a ruptured or damaged diaphragm. In some pumps, leakage can be seen from a weep hole in the bottom of the pump head when solution is forced through the leak in the diaphragm and then pressurized on the backstroke. Looping or bending of the chlorine injection line is a configuration issue where the chlorine injection line is either bent and restricting flow, or the force of gravity is working against the pump, reducing the rate of chlorine injection. Lines should be adjusted so that the flow is not restricted by pinching or mechanical obstruction. Troubleshooting settings will vary by the type of chemical feed pump. The most basic example of this would be that a setting has been inadvertently adjusted or initially set incorrectly. This may require adjusting the pump settings through trial and error. When doing this, it is very important that you record what settings are changed and to what values. This is the only method to track how pump performance is affected by pump settings. When a flow meter is involved, improper flow meter settings can appear to be a pump problem. As an example, we have seen situations where the flow meter was left on factory settings where the range was from 0 to 100,000 gallons per minute. The actual flows were so small that the signal from the flow meter was showing zero flow and the pump would not work. It is important that the flow range is set properly for the existing flows. Pump capacities can sometimes be compromised due to excessive leakage in the distribution systems, creating flows that are in excess of what the chlorination system was designed for. Leak detection and repair is important in proper system operation. Also, if the pump being used is not rated for the correct system pressure, it may appear to be operating correctly, but may not be capable of providing the required amount of chlorine solution into the system. The metering pump pressure rating should be at least 20 psi greater than the distribution system operating pressure. Operator trainers and pump suppliers are able to provide some technical expertise to aid in identifying the issues or to help procure replacement components. Before undertaking any maintenance or repair activities, ensure that the proper equipment or replacement parts are available. You should stock a pump maintenance kit, including a diaphragm, appropriately sized gaskets, valves, a pump head, and O-rings. Parts must be compatible with the pump type and model for the chemical that is being used. Many suppliers will offer pump maintenance kits specific to their products. As mentioned earlier, the stock information may be located on the nameplate. It is very important that you always have a stock of new parts on hand. It may be necessary to replace components in order to determine if that existing part is faulty. Some parts may appear adequate by visual inspection, but are in fact causing the issue. Air bubbles within chemical feed pump tubing can reduce the injection rate of the chlorine solution to the system. In order to get rid of air bubbles, affected lines should be bled. Line bleeding involves disconnecting the tubing, draining all liquid from the line, and repriming the tubing so that no air is present. When you remove the tubing, inspect it thoroughly to make sure there are no flaws or worn sections. You may find that new tubing is required. If it is necessary to prime your pump, refer to the operations manual for the required steps. There is also information available on YouTube from equipment suppliers that provides detailed information on activities such as priming your pump. Some issues that can be encountered when priming the pump include leaks in the suction tubing, priming loss due to non-vertical foot valve. Dry suction heads may need to be primed with water. The discharge valve must be on to create vacuum. The pump primes best with no back pressure. Other issues that can be encountered that will impact the operation of the chemical feed pump include worn seals which require replacement, suction or pressure tubing installed at incorrect locations, and clogged injector fittings. This can be a problem where systems have elevated turbidity, or it could be caused by deposits from the water. In order to ensure that pump components are operating correctly and to avoid potential issues, inspections of the chemical feed pump system should be performed weekly. Weekly inspections should include the solution tanks, pumps, and connections. Operators should look for any signs of leakage or damage and check supply lines for gas bubbles. You should also listen for any unusual noise from the pump, as that may indicate replacement of a pump component is needed. Regular cleaning of pump components should also be conducted during regular maintenance activities. It's very important that observations and maintenance work conducted during weekly inspections is recorded. These records, along with documentation of regular operation and monitoring programs, enable operators to identify trends and changes over time to better operate the chlorine disinfection system. Regular system inspection and maintenance can identify problems quickly, allowing operators to take steps to correct these issues before they become a bigger problem. If issues are not resolved after system maintenance, reach out to your regional operator trainer or pump supplier for additional assistance. A full overhaul of the chemical feed pump should be performed annually. This would include a full maintenance kit and replacing the suction and discharge tubing. The Department of Environment and Climate Change has prepared a standard operating procedure that summarizes the information included in this presentation. This and other resources can be accessed from the department's website. For more information on training opportunities available through the Department of Environment and Climate Change, contact your regional operator trainer.